What we're going to see is that Chapter 7 is a very short chapter. There's only 5 pages. So we'll go through this fairly quickly. But there are a few important concepts that we need to get. Number 1, alkenes. What we find is that alkenes have both a sigma bond, which is going to be here, and the pi bond, which is half of it is on top and half of the pi bond is on bottom. And we've gone over this way back in Chapter 2. The sigma bond is the stronger of the two bonds. It's going to be somewhere around 80 or 90 kcals. The pi bond is the weaker of the two bonds. So when we start adding reagents to alkenes, the pi bond is going to be what breaks first. Now, one of the concepts that's in this chapter is something that we've already covered to a certain extent. Elements of unsaturation. Since we're talking about pi bonds, we're going to use this formula, CnH2n+2, to figure out how many pi bonds or rings a molecule can have. So we know this from before. If we take a simple molecule like butane, 4 carbons, and if I put a hydrogen, the correct number of hydrogens for each carbon, it will correspond to that formula, CnH2n+2. So, 4 carbons will have 2 times 4 is 8, plus 2 more, 10 hydrogens. And that's exactly what C4H10 here has, the butane molecule. Every 2 hydrogens that are missing will mean a pi bond or a ring. Now, we've already gone over that, but the question is, what do we do about halogens? What happens if a molecule has a halogen? And essentially, what we're going to get into is you count the halogen as if it was a hydrogen. In other words, hydrogens form 1 bond in these organic molecules. Halogens form 1 bond. So, if you take off a hydrogen off of butane and put a halogen in its place, well, then you're going to have a formula something like C4H7Br. So, if you're trying to figure out the points of unsaturation and you have halogens in your molecule, then all you do is count them as hydrogens. So C4H7Br, think of it as taking the halogen off, putting hydrogen in its place. That's C4H8. That would have 1 point of unsaturation, meaning 1 pi bond or 1 ring. What do you do with oxygens? Well, what we do with oxygens is we count them, we ignore them. So, I'll give you an example of that. C4H8O is going to behave the same as C4H8. So, if I take C4H8, 4 carbons, and let's say I put a double bond in there. All right. Now, this is not how the molecule looks. We're just keeping track of everything. Okay, so that's C4H8. You have 4 carbons, 8 hydrogens, 1, 2, 3, 4, 5, 6, 7, 8, and nothing else in there. If there was an oxygen in the molecule, look what happens. I'll take out that bond, I'll move this group over, and then I'll put an oxygen in there. Putting an oxygen in does not change the points of unsaturation. So, if you have an oxygen, for purposes of doing points of unsaturation, you ignore it. So C4H8O would have the same number of points of unsaturation as C4H8. The oxygen doesn't change the points of unsaturation. Now, what do we have when we have a nitrogen in there? Well, when you have a nitrogen in there, you're going to count it as half of a carbon, and this sounds really strange, but I'll show you what we mean. So, if I have a formula C3H7N, all right, I'm going to count that nitrogen as half of a carbon. So it would have the same, the C3H7N molecule has the same number of points of unsaturation as C3.5H7. Now, of course, that's an impossible molecule. But the point is, for the purposes of the formula, it works. Okay? So let's go ahead and give an example of that. So, 1, 2, nitrogen, carbon. So I'm going to put a nitrogen in there. And again, if we do the purposes of points of unsaturation, C3.5H7, 2 times 3.5 plus 2, that would be C3.5H9 if it was saturated, but it's missing 2 hydrogens, so 1 point of unsaturation. Anyway, though, let me go ahead and draw a C3H7N molecule, and you see what I mean. Remember, we're talking about stable molecules, not intermediate, so everything has the right number of bonds that it needs to have. So this is an example of a C3H7N molecule right here. And it does have 1 point of unsaturation. So, as a recap, we're going to be using elements of unsaturation in the future. If you just have carbons and hydrogens, then the formula CnH2n plus 2 works fine. If you have a halogen, then what you do is take the halogen off, add another hydrogen in its place, and for the purposes of doing the formula, this is what you would use for figuring out points of unsaturation. If you have an oxygen, for the purposes of doing points of unsaturation, ignore it. And if you have a nitrogen, count it as half of a carbon. And then you still do your same formula for points of unsaturation. And that will tell you how many pi bonds or rings to expect in your molecule. Now, the last thing on this first page is going to be nomenclature. And we have some common names that I want you to know. Ethylene, E-T-H-Y-L-E-N-E, is ethylene, just plain CH2, double bond CH2. Propylene, P-R-O-P-Y-L-E-N-E. These are going to be some common names that you will see occasionally. But most of the time we're going to go to IUPAC, which is on the next page.